Hello everyone, good morning. This is lecture number 19 of ODE. So in this class, we're going to see the continuation of previous class, right? So in the previous class, we have started Cauchy-Euler equations. The previous class, I think we have solved 7 to 8 problems. So we'll continue solving those problems, right? So if you haven't watched all the previous videos, so go back and please watch all the previous videos and come back to this video, right? Super. So far in ODE, we have completed topics such as the first topic is equations, that is solving a differential equations of first order and first degree, right? So there are many methods to solve those equations. So we have finished that. After that, we have started um, this homogeneous second and higher order homogeneous linear differential equations. After that, we have started Cauchy-Euler equations, right? So the previous class, I have given an introduction of how to solve a Cauchy-Euler equation. So we just recall what we did in the previous class, right? So this is the notes of previous class where we have introduced Cauchy-Euler equation or homogeneous linear equations, right? Both are same only. So you will have the general format of a Cauchy-Euler equation is a naught x power n dny by dxn plus a1 x power n minus 1 dn minus 1 by dxn minus 1 and so on. This is general format, right? So for this, what we have to do is we have to use substitution, put x equal to e power z. So that means z will be log x, right? So by this substitution, this Cauchy-Euler equation, after the substitution, this Cauchy-Euler equation reduced to a second or higher order linear differential equation with constant coefficients, right? That is what we discussed in the previous class. You can see after the substitution, this has been reduced to a second and higher order linear differential equations of constant coefficients, right? After that, we know how to solve these kinds of equations, right? You have to use those methods to solve these equations. So again, I'm repeating, go back and watch all the previous videos before watching this video if you haven't watched all the previous videos, right? So we have to replace this x square d square by d1 minus 1 xt by d1 and so on, right? Super. So in the previous class, we have solved almost yes. So we have solved 8 problems in the previous class. Now we'll start with 9th problem, right? So we will solve another 7 problems in this class, and then we will wind off this topic, right? Yes. Overall, we're going to solve around 15 problems. We will solve those, and then we'll go back to the next, and then we'll come back to the next topic, which is variation of parameters, right? Okay. So we move on to 9th problem. We move on to 9th problem. Ninth problem. So solve x square d square y by dx square so solve x square d square y by dx square minus 2 times x into dy by dx plus 2y is equal to x plus x square log x plus x cube, right? So very easy. So you can see this is a Cauchy-Euler equation, right? This is a Cauchy-Euler equation. So we have to replace solution. So I'll do this fast. I'm assuming that you have watched all the previous videos, right? Okay. This equation is same as x square d square minus 2xd plus 2 times y is equal to x plus x square log x plus x cube, right? Where what is d? Okay, this d is d by dx, right? Okay. Now what we have to do? We have to replace x square d square by d1 into d1 minus 1 xd by d1, right? We have seen in the previous class. What is d1? d1 is d by dz. Okay. So put x is equal to e power z. This implies my z will be log x, right? Take log on both sides. And you have to replace this by d1 into d1 minus 1 minus 2 times xd by d1 plus 2 times y is equal to x is e power z. This is x is e power z, so e power 2 is z, and we know z is log x. This will be e power 3z, right? Yeah, because you just put x is equal to e power z and z by log x, right? Okay. So this is same as if you multiply here, we will have d1 square, where this d1 is d by dz, right? So d1 square minus d1 minus 2d1. So this will be minus 3 times d1 plus 2 of y is equal to e power z plus z into e power 2z plus e power 3z, right? So we will find general solution. Therefore, the general solution is given by y is equal to CF. I'm going to call this as PA1, PA2, PA3, right? I'm going to find separately. So PA1 plus PA2 plus PA3. So we'll find characteristic function. We'll find PA1, PA2, PA3, and then we'll do, right? Okay. Now to find characteristic function, right? So to find CF, what is the auxiliary equation? It is m square minus 3m plus 2 is equal to 0, right? M square minus 3m plus 2 is equal to 0. So solve this, you find the roots, right? So m is equal to minus b plus or minus root of b square minus 4 times ac divided by 2 times a. So we will have 3 plus or minus, so 9 minus 8 is 1 by 2. So 3 plus 1, 4 by 2 is 2. We will have 1 and 2, right? So 3 plus 1 by 2 is 4 by 2. 4 by 2 is 2. 3 minus 1 by 2 is 2 by 2. So therefore, the roots are real and distinct. CF is C1 e power. Remember, here it is in d by dz, right? So it means it will be e power 1 z plus C2 e power 2 z, right? We will have m1z. If we have in d by dx, you will have C1 e power m1x plus C2 e power m2x, where m1, m2 are the distinct roots. But here it is in z, so you just replace C1 e power z plus C2 e power 2z. 1 and 2 are the roots. Now we know z is log x, right? We know z is log x, so revert the substitution again. So z is log x, and this will be C2 e power 2 log x. This same as e power log x is x. You just take this 2 to the power, you will have x square. So e power log x square is x square. So C2 x square. This is your characteristic function. Now we'll find PA1, PA2, PA3. So PA1 is 1 by f of d. So f of d is d1 square minus 3 times d1 plus 2 e power z. So this is a type 1 linear differential equation of constant coefficient of order 2. So what you have to do? Replace d by a. What is a? E power a z, right? If you have e power 1 by f of d e power a z, means you have to replace z by a. So a is 1 here, right? Because 1 into z, coefficient of z. So if we replace 1, we will have 1 minus 3 plus 2 e power z. So you can see this is 0, right? 1 minus 3 is minus 2, minus 2 plus 2 is 0. That means what you have to do? Multiply 1 z and differentiate the denominator. So d1 square is 2d1 minus 3, right? Minus 3 e power z. See, in the previous videos, we'll multiply x and then we'll differentiate denominator. But here everything in terms of z, right? That means you have to, here the independent variable is z, right? So therefore, z into 1 by differentiate this 2d1 minus 3 e power z. Now again you replace d by a. So a is 1 here. So if we put 1 here, we will have z into 1 by 2 into 1 minus 3 e power z. So this is minus 1, right? So minus z e power z is our PA1, right? Minus z e power z is our PA1. Now if in PA2, or you can also replace z to be log x here itself, right? Okay. PA2 is 1 by f of d, so d1 square minus 3d1 plus 2. What is PA2? It is z e power 2z, e power 2z into z. So this is type 4, right? E power ax into v. So what you have to do? First you put what you have to do? Replace d1 by d1 plus 2. That's what you will do, right? So if you have e power az, so replace d1 by d1 plus 2. So therefore this work is completed. So take this e power 2z outside. So 1 divided by that is we have to find f of d1 plus a, right? That will be d1 plus 2 whole square minus 3 times d1 plus 2 into z, right? So if you have e power ax into v, this is type 4. Just go back and watch previous videos if you are not comfortable with this, right? All that it will be very easy when if you have watched all the previous videos. So you have to replace this d1 by d1 plus 2, right? E power a z. Okay, this will be e power 2 z 1 divided by, so d1 square plus 4 times d1 plus 4, right? A square plus 2ab plus b square minus 3 times d1 minus 6 plus 2 into z. This will be e power 2z 1 divided by, so we will have d1 square, so 4 d1 minus 3 d1 is plus d1, 4 minus 6 is minus 2, minus 2 plus 2 is 0. So we will have 4 minus 6 is minus 2, minus 2 plus 2 is 0. So we will have 1 by d1 square plus d1 of z, right? So what we will do? What we will do after this? To take this d1 outside, right? So e power 2 is at 1 divided by, so if we take this d1 outside, we will have 1 plus d1 square by d1 of z. So this is e power 2 is at 1 by d1, 1 plus d1 whole power minus 1, right? So 1 d1 will get cancelled into z. This will be e power 2 z into 1 by d1. So expand this, 1 plus x whole power minus 1, 1 minus d1 plus d1 square minus d1 cube and so on up to z. So d1 means, what is d1? d1 is d by dz, right? So differentiate this. So this will be e power 2z into 1 by d1 of z into 1 is z, d1 of z. We have to differentiate this z one time. That means it will be 1. Every term will be 0 after this, right? So what is d1? d1 is d by dz. d by dz of z is 1. d square by dz square of z is 0, right? If you differentiate this twice, it will be 0. So 1 by d1 means you have to integrate this. 1 by d1 means you have to integrate this. So integration of z minus 1 dz. This will be e power 2z into z square by 2 minus z, right? Z square by 2 minus z. This is your PI2, right? Okay. This is your PI2, right? E power 2 is z square by 2 minus z. See, this is type 4, right? So if you have watched all the previous videos, you have classified the second and higher order linear differential equation with the constant coefficients. There we have classified into type 1, type 2, type 3, type 4, type 5 and type 6, right? This comes under type 4. Type 1 is RHS is e power ax. Type 2 is sin ax or cos ax. Type 3 is what? Actually comes to type 3, right? E power ax into v. E power ax into v, right? Type 3 is polynomial in x. Type 4 is e power ax into v. That is what I'm doing here. It is very simple. So make sure you have watched all the previous videos, right? Okay, is there any doubt up to now? Is there any doubt up to now? Very simple, right? Okay, so PI2, PI3. So 1 divided by d1 square minus 3d1 plus 2. What is PI3 is e power 3z, right? E power 3z. What we have to do again, it is considered type 1 of a second order linear differential equation constant coefficient. Put z is equal, replace d by a, right? Replace d by a. So replace d by a, e power a is z. So a is 3 here. So replace a by 3. So d1. So you replace d1 by 3, 3 square is 9. 3 into 3 plus 2 e power 3z. These two will get cancelled. So denominator is non-zero. That means this is the required particular integral PI3. Therefore, the general solution is y is equal to CF plus PI1 plus PI2 plus PI3. So what is CF, which we already found, right? C1x plus C2x square plus PI1. So PI1 is minus z e power z. Minus z e power z. PI2 is e power 2z. E power 2z into z square by 2 minus z plus pi3, which is 1 by 2 e power 3z, right? Solution must be in terms of x. It must be in terms of x. So you have to replace again z by log x. So c1x plus c2x square. This we are already done, right? So replace z by log x, e power log x, e power 2 log x, replace z by log x whole square by 2 minus log x plus 1 by 2 e power 3 log x, right? Because z is log x. This is same as c1x plus c2x square minus log x into e power log x is x, right? E power log x is x. Again, this will be x square, right? Because I can take this 2 to the power. So we will have e power log x square. And we know e power log f of x is f of x. And this will be log x whole square by 2 minus log x plus 1 by 2 x cube, right? Take this 3 to the power. So e power log f of x is f of x. So we will have x cube. So this is the required solution. This is the required solution. Okay. Clear? I'll move on to 10th problem. So solve x power 4 d cube power 4 d cube power 4 d cube plus 2 times x cube d square minus x square d plus x of y is equal to 1. Right? Remember, this is not Cauchy Euler. For Cauchy Euler, this x power and d power both has to be same, right? That is d cube. If you have x cube means it will be Cauchy Euler, but you can see x power 4 here we have x square d square xd. So what I'm going to do is this I'm going to rewrite this equation, right? So if I divide by 1 by x, what you will have? I'm going to divide throughout by x. I'm going to divide throughout by x or multiply 1 by x. If I divide throughout by x, this is same as x cube d cube plus 2 times x square d square minus xd plus 1 of y is equal to 1 by x, right? What I'm doing is I'm just dividing throughout by x, right? Dividing by x. And this x is non-zero. So now you can see this becomes a Cauchy Euler equation, right? Of order 3. So what you have to do, put x equal to e power z. So that means z will be log x, right? So therefore this will become, so we have to read here we have third order. That means you have to replace this by d1 minus 1 d1 minus 2, right? This is the substitution for x cube d cube plus 2 times x square d square. So it will be d1 minus 1 minus xd is d1 plus 1 of y is equal to 1 by e power z. What is d1 here? d1 is d by dz. What is d here? d is d by dx, right? So this is same as just simplify this, right? So we will have d1 into it will be d1 square minus 2d1 minus d1. So it will be minus 3d1 plus 2, right? Plus 2 into d1 square minus d1 plus 1 of y is equal to e power minus z. Very simple. It comes under type 1, right? Okay. So that multiply again this d1. So we will have d1 cube minus 3d1 square plus 2d1 plus 2d1 square minus 2d1 minus d1 plus 1 of y is equal to e power minus z. So we will have d1 cube, so minus 3d1 square plus 2d1 square. So it will be minus d1 square. So 2d1 will get cancelled. So we will have minus d1 and we have plus 1 of y is equal to e power minus z, right? This is what we will have. Okay. Now, what is the solution? The general solution is given by y is equal to cf plus pi. We have only one in the one term in the RHS, right? So what is CF? So we will find CF. So the auxiliary equation is m cube minus m square minus m plus 1 is equal to 0. So we will have three roots here. So you can see clearly 1 is one root, right? Because 1 minus 1 is 0, minus 1 plus 1 is 0. So we will have 1 is one root. So to find other two roots, use synthetic division. What is the quotient here? 1, minus 1, minus 1, 1. You have to start with 0. 1 plus 0 is 1. 1 into 1 is 1. 1 minus 1 is 0. 1 into 0 is 0. Minus 1 plus 0 is minus 1. 1 into minus 1 is minus 1. This is the quotient of the other roots are solutions of x square minus 1 is equal to 0, because this is x square term coefficient, this x coefficient, this is constant term. This implies x is equal to plus or minus 1, right? So therefore, what is the root? So therefore, the roots are 1, 1, minus 1. So we have two equal roots and one distinct roots. What is your CF? What is your CF? For two real roots, for two equal roots, what will the characteristic equation? Is C1 plus C2Z e power that distinct root into Z. Right? Usually we will have x here, right? C1 plus C2x e power m1x. But everything it is in terms of Z, because the independent variable is Z now. Plus, and for this distinct root, we will write C3 e power minus Z. Right? This is your characteristic function. Everything you have to write in terms of Z, right? Okay. So you have to again you replace Z by log x. So e power log x, C3 e power log x. This is same as C1 plus C2 log x into x. This is 1 by x, right? So C3 into 1 by x. So take this minus 1 to the power. So we have x power minus 1. So e power log x power minus 1 is x power minus 1 only. This is your CF. Now we'll find pi. So it is 1 divided by f of d1. So d1 cube minus d1 square minus d1 plus 1 e power minus z. So replace d1 by a, which is minus 1 here, right? This is minus 1. So therefore this will be 1 divided by, so minus 1 whole cube is minus 1, minus d minus 1 square is minus 1. This will be plus 1. This will be plus 1 into e power minus z. So you can see this will be 0, right? 2 minus 2 will be 0. So what you have to do? Multiply 1 z, differentiate the denominator. So 3d1 square minus 2d1 minus 1, right? Differentiate this. 3d1 square minus 2d1 minus 1 e power minus z. So again you replace d1 by minus 1. So we'll have z into 1 divided by 3 into minus 1 whole square, 2 into minus 1 e power minus z. So it will be 3 z into 1 divided by 3 plus 2. So 3 plus 2 is 5 minus 1 e power z. So you will have 3 plus 2 is 5, 5 minus 1 is 4. Z by 4 e power minus z is your required partial integral. So replace z by log x. So log x by 4 e power minus log x. This is same as e power log x is 1 by x. 1 by x log x by 4, right? 1 by x log x by 4 is your particular integral. So therefore, general solution is y is equal to CF plus PI. So C1 plus C2 log x into x plus C3 into 1 by x plus 1 by x log x by 4. This is your, that is CF plus PI, right? So I'm just adding this and this to get your general solution, right? Is it clear? Okay, so we'll move on to next problem. So solve d square y by dx square. Solve d square y by dx square plus 1 by x dy by dx is equal to 12 log x by 12 log x by x square, right? Okay. So by looking itself, you don't judge that it is not Cauchy Euler. If you multiply by x square, what will happen? It will become Cauchy Euler, right? If you multiply by x square, uh, it will become Cauchy Euler, right? So multiply by x square is the same as, so multiply by x square. So we will have x square d square y by dx square. Multiply by x square, 1x will get cancelled. So x into dy by dx. And multiply by x square will get cancelled. So we will have 12 log x, right? What I did, I have multiplied by x square. Now you can see the Cauchy Euler, right? X square d square by dx square. This order and this power has to be same. So what you have to do, put x is equal to e power z. So that means z will be log x. So therefore this will be replace x square d square by d1 into d1 minus 1, and this is d1 is equal to 12 times log x, and we know log x is z. So after this substitution, everything will be converted in terms of z. Where what is d1? d1 is d by dz. This is same as d1 square. So we can see this minus d1 plus d1. We will have y here, right? We will have y. Right? So we will have y is equal to 12 z. This division is same as x square d square plus xd of y is equal to 12 log x, right? Yes. So these two will get cancelled. So we will have d1 square of y is equal to 12z, right? d1 square of y is equal to 12z. Okay. Now you can see y is your general solution, right? You can do by what you can do. You can do by, you can do in several methods. Okay, let us do by normal method, right? General solution is y is equal to cf plus pi. So what is your cf? We have only m square is equal to 0, right? So we have auxiliary equation is m square is equal to 0. That means m is equal to 0, 0. So we have two equal roots. That means your cf is c1 plus c2 is z e power that root into z. So e power 0 is 1. So that means you will have c1 plus c2, and you know z is log x. So c1 plus c2 log x is your characteristic function, right? c1 plus c2 log x is your characteristic function. Okay. Now we will find particular integral now. To find pi, so 1 divided by f of d1. So 1 divided by d1 square into 12z. So just integrate this twice, right? Just integrate this twice. So this is 1 by d1 of, so we integrate once, so 12 into integration of z is z square by 2. And if we integrate again, we will have 6 into integrate z square. So we will have z cube by 3. So we will have 2z cube. Replace z by log x. So 2 log x cube is your required particular integral, right? So therefore, general solution is y is equal to cf plus pi. So cf is c1 plus c2 log x plus pi is 2 log x cube, right? So we'll move on to 12th problem. Okay. So we will have x cube d cube a very easy problem, right? I'm skipping easy problem. I'll do that. I'll give you exercise problem, right? All x cube d cube by dx cube dx cube plus 2x square d square y by dx square plus 2y is equal to 10 into x plus 1 by x. Right? You can see it's a Cauchy Euler equation. So we have x cube d cube x square d square plus 2 times y is equal to 10 into x plus 1 by x, right? So what is d here? This d is d by dx. Now you have to do substitution. Put x equal to e power z. This implies z will be log x, right? So you have to replace x cube d cube by d1 into d1 minus 1 d1 minus 2 plus 2 times d1 into d1 minus 1 plus 2 times y is equal to 10 times, we know x is e power z. So e power z plus e power minus z, very easy. Both are type 1 only. So if you just simplify this, right? So d1 square, d1 into d1 square minus 3d1 plus 2, right? d1 square minus 2d1 minus d1 will be minus 3d1 plus 2 times d1 square minus 2 times d1 plus 2 of y is equal to 10 into e power z plus e power minus z. So this will be d1 cube, right? d1 cube. Here we will have minus 3d1 square. So minus 3d1 square plus 2d1 square. It will be minus d1 square, right? And here you will have 2d1 minus 2d1 will get cancelled. So we will have plus 2. Is it clear? So we will have d1 cube minus d1 square plus 2 of y is equal to 10 times e power z plus e power minus z, right? Okay. So therefore, the general solution is given by y is equal to cf. You can multiply 10 inside, 10 into e power z plus 10 into e power minus z. So pi1 plus pi2. Right? So first you find the cf. So CF is, what is the auxiliary equation? M cube minus m square plus 2 is equal to 0. So we'll have 3 roots. First root you have to do by trial and error method, right? So clearly 1 is not a root. Minus 1, what will happen if you put minus 1? So this will be minus 1. Yes, minus 1 is the root, right? So because minus 1 is minus 2. Minus 2 plus 2 is 0. So minus 1 is 1 root. So m cube coefficient is 1. M square is minus 1. There is no m term. So put 0 and we have constant term. So m cube, m square, m constant. So 0, 1 plus 0 is 1. Minus 1, minus 2, should be plus 2, 2, minus 2 will be 0. So other two roots are the solutions of m square minus 2m plus 2 is equal to 0. So solve this, you will have m to be equal to 1 plus or minus I, right? Use the quadratic formula, minus p plus or minus root of p square minus 4ac by 2a. You will have 1 plus or minus I. Therefore, the roots are 1 and 1 plus or minus I. So we have one distinct root and one pair of complex roots. So this is alpha plus or minus I beta. So one pair of for distinct root, I'll put c1 e power z, and for this e power alpha z into c2 cos beta z, beta is 1 again, plus c3 sin beta z. This is your characteristic function, right? So you have to replace z by log x. So it will be x because e power log x is x, and this again x, c2 cos log x plus c3 sin log x, right? Okay. So this is your characteristic function. Now we will find particular integral pi1. So pi1 is 1 divided by d1 cube minus d1 square plus 2 of 10 times e power z, right? 10 times e power z. So take this 10 outside and put replace d by a. So a is z. So replace d by 1. So it will be 1 minus 1 plus 2 e power z. So we will have 5 e power z is your pi1. So replace z by log x. So 5x is your pi1. Now similarly you find pi2, so 1 divided by d1 cube minus d1 square plus 2, 10 into e power minus z. Now if you put d1 to be a, is d1, right? So a is minus 1 here, so we will have this to be 0, right? Because minus 1 is minus 2 plus 2 is 0. So what you have to do, multiply 1z, differentiate the denominator, so 3d1 square minus 2d1 e power minus z. Now again you replace d1 by a is minus 1 again, so you will have 10z into 1 divided by 3 into minus 1 square is plus 1, 2 into minus 1 e power minus z. So 3 plus 2 is 5. 5 by 10 is 10 by 5 is 2. So we will have 2z e power minus z. So replace z by log x. So it will be e power minus log x, which is x power minus 1. So 2 log x into 1 by x is your pi2, right? Okay. So therefore, general solution is y is equal to cf plus pi. Substitute this cf and substitute pi1 plus pi2. You will get the required solution, right? Okay. Actually, there is heavy rain outside, so I just save this. Actually, it is summer time in Chennai, but we are getting rain here. Is it clear, right? So far, super. So we have done, I think, yes, 12 problems. So another 3 more problem. We will wind up this topic. So we'll come back to 13th problem. 13, 14, 15. So another 3 problem we will do, and then we'll wind up this topic. After we will solve variation of parameters. I'll give you an exercise problem, right? I'll give you some exercise problem. To solve x cube d cube by dx cube plus 2x square. Right in the next page. Solve x cube d cube by dx cube plus 2x square d square y by dx square plus 2y is equal to 10 into x plus 1 by x, right? Very simple, right? So here we have the same question. Oh, okay. This is not your den, right? Sorry. Solve x square d cube by dx cube plus 2x into d square y by dx square plus 2 into y by x is equal to 10 into 1 plus 1 by x square, right? Now what happens if you multiply by x? What happens if you multiply by x? So if I multiply by x, this will become x cube d cube y by dx cube plus 2x square d square y by dx square will be 2y is equal to 10 into x plus 1 by x, right? If you multiply by x, 1x will get cancelled, which is same as the previous problem, right? Same as previous problem, x cube d cube y by dx cube plus 2x square d square by dx square plus 2y is equal to 10 times x plus 1 by x, right? So if this problem is asked me, should just multiply by x, both problem will be same, right? Actually, this is a 1999 question. UPSC. This is 2006 question. See, both are same only, right? This is IAS 1999. If I multiply by this, if I multiply this by x, this will become same as this. So both are same question only, right? We get the same solution only. So we move on to 13th problem. So solve x square d square plus xd plus 1 of y is equal to log x sin log x sin log x, right? Okay, so we'll do this very simple only, right? Don't get panic by seeing the questions, are very easy. So it's a Cauchy Euler equation. So put x is equal to e power z. This will become, this implies z will be log x, right? So if we have any outside disturbance, please adjust with this, right? Because I'm getting heavy rain outside, there can be some noise. We will quickly finish another 3 problems and then wind up this topic. Okay. Yes, analytical sum and completed only 2 topics, which are direction coefficient, direction ratios, and planes. So other topics are still left, right? I will complete those remaining topics after completing ODE. So this will become d1 into d1 minus 1, xd is d1 plus 1 of y. So z is log x, will be z sin z, right? So this is d1 square. So minus d1 plus d1 will be 0, right? d1 square minus d1 plus d1 plus 1 of y is equal to z into sin z. This will get cancelled. So we will have d1 square plus 1 of y is equal to z into sin z. So this d is d by dz. This d1 is, sorry, d is d by dx. d1 is d by dz. Okay. So the general solution is y is equal to cf plus pi. So to find cf, what's the auxiliary equation? It is m square plus 1 is equal to 0. So that means m is equal to plus or minus 1, right? Sorry, plus or minus I. So therefore, we have 0 plus or minus I. So your CF is e power alpha x, e power alpha z, C1 cos beta z, beta is 1, alpha plus or minus I beta, alpha is 0, beta is 1. So this will be 1. So C1 cos z plus C2 sin z is your CF. So C1 cos log x, C2 sin log x. This is your characteristic function. This is your characteristic function. Now you will find PI, right? So you will find PI. So 1 divided by f of d. So d1 square plus 1. Z into sin z. See, we have already done this, right? X into P. You already know the formula, right? Okay, I'll just show you the previous. This comes under what? This comes under type pi, right? So you can see. So type 4 is e power x sin x. So it comes under type pi, right? So you can see x into v, right? X into v. Here we have z into v. This v is a function of x, there z is v is a function of z. Okay, so what we know? So we know it is 1 by f of d xv is x into 1 by f of d into v minus f dash of d by f of d whole square into v. You can do like this, or you can also do like this method, right? Real imaginary part of or real part of. If you have watched this video, you would have great clarity, right? So I'm going to apply the formula now. So we know 1 by f of d z into v. So 1 by f of d z into v. So here v is a function of z, which is sin z. So what is formula here? 1 by f of d z into 1 by f of d into v minus f dash of d by f of d whole square into v. This is what the formula is, right? You can see 1 by, so x into 1 by f of d into b minus f dash of d by f of d whole square into b. Now we will apply this formula here to get the answer. So this is z into 1 by f of d, this is f of d1, right, into b minus f dash of d, differentiate this, so we will have 2d1 f of d whole square, so d1 square plus 1 whole square into sin z, right. Now you can, this comes under type 2, right, so sin a z, so replace d1 by minus of a square, so a is 1, so it will be minus 1. So if we replace, it will be minus, if we replace by minus 1, we will have 1 divided by minus 1 plus 1, right? Minus 1 plus 1, minus 1 plus 1 sin z. If d1 square by minus 1, minus 1 plus 1 whole square sin z. Now you can see denominator is 0. So denominator is 0, what you have to do? Already we have one z, multiply one z, differentiate the denominator, so we will have 2d1 sin z, right? And again we have 2d1 here, differentiate the denominator, we will have 2d1 square plus 1. Okay, let us, actually this will go long, I think. Okay, before that what we will do is, we will expand this, right? What we can do is, we will expand this. Okay, let it be like this. So if I expand d1, if I expand d1 square plus 1 whole square, so we will have a square plus 2ab plus b square, right? So if we differentiate this, we will have 4d1 cube, 4d1 cube plus 4d1, right? 4d1 of sin z. See, if we have denominator, if denominator is 0 means you have to multiply one z and differentiate denominator, right? Let us multiply one z here. So multiplying an z and differentiate the denominator. So we will have z squared by 2, 1 by d1 of this integration, right? And again you can see, if I replace, what we will have is, replace d1 square by minus 1. So therefore your d1 cube will be d1 square into d1. So it will be minus 1 into d minus d. So that means I can replace this d1 cube as minus d1. So we will have this to be 2d1 divided by 4 times d1 is, this is minus d1 plus 4 times d1 of z into sin z. Now you can see again denominator is 0, right? Again denominator is 0. So differentiate this once again. So this will be z square by 2. Integration of sin z is minus cos z. This term is over now, right? This part is over now. So here we have 2d1. Differentiate this denominator once again. So 12d1 square plus 4. Multiply on z again. So we will have z square sin z, right? Z square sin z. So this will be z square by 2 cos z, or you can also approach by imaginary part of e power I z. You can also do like this also, right? Okay. Here we will, again you replace this d1 square by minus 1. So we will have minus 2 d1 by, so d1 square by minus 1. So minus 12 plus 4 will be minus 8 z square sin z, right? That is, I'm replacing d1 square by minus 1, right? So we will have this to be equal to z square by 2, z square by 2 cos z plus plus d1 by 4, d1 by 4 z square sin z, right? Z square sin z. So d1 means what? You have to differentiate this. So z square by 2 cos z plus 1 by 4. So differentiate this, right? So z square, derivative of sin z is cos z plus sin z into 2z. I'm applying product rule, right? This is your required particular integral, right? This is your required particular integral. Okay. So 1 by 4 This is z square by 2 cos z, z square by 4 cos z, 2z sin z by 4. So this is what? Okay, done. Any mistake we have made here? By 4. Integration of minus cos z. Okay, so minus. Okay, so here you have minus z square by 2, right? Sorry, minus z square by 2 cos z. So multiply into 2 into 2. So z square to minus 2 z square plus z square will be minus z square by 4 cos z. And here we have um, so it is 2d1 into 4d1 cube plus 4d1 will be d1 d1 square is minus 1, minus 12 plus 4 is minus 8, d1 by 4 z square sin z, right? So we have minus z square by 4 cos z plus if I cancel this, we will have z sin z by 2, right? I think we are missing some 2 is there any mistake I have made here? Not denominator, last 5 lines is not. Where I made mistake? D power 4 plus 2d square plus D power 4 D1. I think it is correct only, right? But here we should have 4 here. I don't know where I missed one number. But in book we have 4 here. I don't know whether it is, we have 4 here in the book. Z sin Z by 4. So here we have 4 in the book, right? So just check once. Here we have 4 in the book, right? If you are getting 2 also, it is correct only. In book it is 4 here. So you just do this once again, right? I don't know whether I have made mistake or not. 1 by f of t into b minus f dash of t whole square. F dash of t is 2d1 divided by f of d1 whole square. So d square ab plus we have d1 power 4 plus 2 d1 square plus d. So this will be d1 power 4 d1 cube 4 d1 cube plus 4 d1 by multiplying z here. Now 12 d1 12 d1 12 d1 square plus 4 d1. Okay, you just check this, right? The book you are getting this as 4. And also they have done in the method of imaginary part of this is what imaginary part of e power I z, right? Sin z is imaginary part of e power I z. I just give the solution also, right? I will just give their solution also. I'll just check with this, right? Just check, just you do by this method also and see whether you are getting the same answer or not. So this is the particular integral they have given, right? So they have done by they have did sin z as e power I z, right? This also we can do easily. We have already done this in this method also, but you can see the solution is 1 by 4 z sin 1 by 4 is common. So if I take 1 by 4 common here, we will have minus z square cos z. So we are getting minus z square cos z. But here we have z sin z by 4. But we have z sin z by 2 here. Right? I don't know whether it. Okay, let us check this problem. You check this again. You also do by this method also and see whether you are getting 2 or 4. Right? Okay. So we'll move on to the last problem. After that, we'll wind off this session. Don't get confused by this method. This method is very easy, right? So if you have seen previous videos, I've also did the problem by this method also, right? Okay. So we'll move on to 14th problem and then we'll wind off. After that, I'll give you some exercise problem diagram. Okay. Find the values of lambda. Find the value of lambda for which all solutions for which all solutions of x square d square y by dx square minus 3x dy by dx minus lambda y is equal to 0 tends to 0 as x tending to infinity, right? Very interesting problem. So we need to find all values of this lambda, right? We need to find all values of lambda such that the solution of this equation must tend to 0 as x tend to infinity, right? Super. So we'll do this problem now. So this given equation is same as x square d square minus 3 times xt minus lambda of y is equal to 0. It is a Cauchy Euler equation. It comes at a time 0, right? Okay. So put x is equal to e power z. So this implies z is equal to log x. This will become d1 into d1 minus 1 minus 3 times d1 minus lambda of y is equal to 0. So we have d1 square. So minus d1 minus 3d1. It will be minus 4d1 minus lambda of y is equal to 0. Right? So what is the general solution? We have d1 minus 1. Yes, sorry. Actually the question is d1 square isn't is plus. Sorry. So this will be plus 2d1. Sorry. Minus d1 plus 3d1. Therefore, the general solution is what? You can see it is reduced to a second order linear differential equation constant coefficient. The solution is y is equal to CF alone, right? What is your CF? So to find CF, what's the auxiliary equation here? M square plus 2m minus lambda is equal to 0, right? Find all values of lambda. This lambda has to be a real number, right? Because you are finding only real solutions. Now what is the root here? So m is equal to minus b plus or minus root of b square minus 4 times a into c divided by 2 times a. So minus 2 plus or minus root of 4 plus 4 lambda divided by 2. This is same as you take this root 4 outside, so you will have 2, cancel this 2 again. So you will have minus 1 plus or minus 1 plus lambda. This is your, you can see we have two distinct real roots, right? Two distinct real roots. And remember, we have one important condition here. What's the important condition? Root x is defined when x is greater than or equal to 0 only, right? For real solution, for real number, root x will be real number if this x is greater than or equal to 0 only. We are finding real solution only. So make sure this 1 plus lambda is greater than or equal to 0. Then only we will have root of something is defined. If the number is real number. So that means lambda should be greater than or equal to minus 1. Mark this as very, very important condition, right? So for this has to be find all values of lambda. Actually in the question they have to say find all values of real lambda, right? Find all values of real lambda they should have mentioned, but they didn't mention, right? Okay, but we will assume that this lambda is a real number, right? Okay, actually there is some fault in the question, but okay, find the real values of lambda. We will reorder this. Okay, so for this lambda has to be greater than or equal to minus 1, right? If there is no constraint on lambda means if there is no real values means this we can leave as it is, right? If it is real means this 1 plus lambda has to be greater than or equal to minus 1, right? Okay. So lambda is okay. Now we have two distinct roots, right? Roots are real and distinct. So what is the roots? Minus 1 plus root 1 plus lambda, minus 1 minus root 1 plus lambda. So what is your CF? C1 e power m1 m1x. Actually it is z, right? Because d is d1 is d by dz. So C1 m1z, C2 e power m2z. So C1 e power m1. So what is m1? Minus 1 plus root of 1 plus lambda into z. C2 e power minus 1 minus root of 1 plus lambda into z. Right? Okay. Now we have to replace z by log x, right? Z by log x. So this will be C1 e power minus 1 plus root of 1 plus lambda into log x. C2 e power minus 1 minus root of 1 plus lambda into log x, right? Now this is same as you take this to the power, right? And e power log x is x. So this will become, this is same as C1 x power minus 1 plus root of 1 plus lambda, C2 x power minus 1 minus root of 1 plus lambda, right? Now remember, very important thing now, right? So we have C1 x power minus 1. Okay. I can write this as C1 x power, take minus outside, 1 minus root of 1 plus lambda, right? And here also, if I take minus outside, 1 plus root of 1 plus lambda, right? This is your solution. Now, we need to find the value of lambda such that the solution of this equation must tend to 0 as x tend to infinity, right? Now, as x tending to infinity, the solution must tend to 0. That means what? That means what? What do you have to do? This number has to be strictly greater than 0. Then only we will have x power minus of some number that is strictly greater than 0. So I can write this as 1 by x square. This tend to 0 as x tend into infinity, right? So this number has to be strictly greater than 0. Suppose if this number is negative, means minus minus will become plus. This will tend to infinity. But our solution has to tend to 0 as x tend to infinity. That means this number, that is this number, has to be strictly greater than 0. Right? This number has to be strictly greater than 0, right? Since the solutions must tend to 0 as x tend to infinity, right? So this number 1 minus root of 1 plus lambda has to be strictly greater than 0, right? Then when we have negative number, so negative number means I can write this as 1 by something, that 1 by something will tend to 0 as x tend to infinity, right? So that means 1 by 1 plus lambda is strictly greater than 0. So 1 is strictly greater than root of 1 plus lambda, right? 1 is strictly greater than root of 1 plus lambda. This is same as root of 1 plus lambda is less than 1. So square on both sides, right? So if I square on both sides, we will have 1 plus lambda is less than 1. This implies lambda is less than 0, right? Call this as double star. Call this as double star. Call this as double star. So you can see we have lambda should be greater than minus 1. So from star and double star, from star we have lambda should be greater than or equal to minus 1 and lambda should be less than 0, right? Therefore, what is the value of lambda? Minus 1 plus minus 1 to 0 is your required values of lambda, which are the required values of lambda, right? This is a solution. So if your lambda lies between minus 1 to 0, then the solution of this equation will tend to 0 as x tend into infinity. That's what it means, right? And also this will be defined because this lambda is simply greater than minus 1. So See, you have to find all values of lambda that satisfies both the thing, right? So therefore, -1 to 0 is the values of lambda that is common to both these lambda, right? This is the required values of lambda. So that's it. So we'll stop Cauchy-Euler equation. So I did 14 problems. I'll give you some more problems in Telegram group. After that, we're going to start variation of parameters, right? So the next class we will start a variation of parameters, right? Okay. So is there any doubt up to now? Okay. If no doubt, we will wind off. See you in the next class, right? Thank you. Bye.